Hello. Now I would like to discuss periodic phenomena. What is the periodic phenomena? This is the definition of periodic phenomena. A periodic phenomena is a phenomena that repeats itself with a regularity, fixed regularity. Certain periodic phenomena can be described with the periodic functions. Periodic phenomena is the phenomena which repeats itself after some regular interval of time, after some fixed period of time. Uh, Same phenomena is repeated. So, such a phenomena is called the periodic phenomenon. I have few examples to explain this. These are some natural periodic phenomena. First one is the pendulum movement of the clock. This is the pendulum movement of the clock. This is a pendulum. What is the pendulum? It is a string which is hang vertically to some support, and at its other end, a small bob is attached, metallic bob. If we displace it in this way at to some fixed point, then if we leave it, it moves in this way and then comes back here. It repeats its motion after some regular interval of time. So this is an example of the periodic phenomenon. Second one is the heartbeat of the human. So for some certain person, uh, in normal circumstances, any human being has its rate of some rate of its his heartbeat. This heartbeat is being repeated again and again after some fixed time. Now, next example is the height of the water at low and high tide. So, you know, at the surface of the sea, or anywhere where water is moving, its tides uh, are being changed after some regular interval of time. So this is also a natural example for the periodic phenomenon. That's one excellent example for the periodic phenomenon. Spin rotation of the Earth around its own axis. I think from the billion trillion years, this phenomena is the best phenomena which is repeated with same regularity. It never changed. Earth completes its rotation, uh, spin rotation about its own axis in 24 hours, and it is fixed. It is never changed. So this is the best example for the periodic phenomena. Next is again now orbital rotation of Earth around the Sun. Spin rotation is what is the period of the rotation? It is 24 hours. After 24 hours, uh, the Earth came back to its earlier position. Now, in the orbital motion of the Earth around the Sun, so since orbital motion of the Earth around the Sun is responsible for the weather changes, and we know that this is 1 year. In 1 year, uh, the Earth completes a revolution around the Sun. So these are the few very good examples for periodic function. Okay, now I'm going to explain this mathematically. So, what is the definition of periodic function or period? A function f is the period if there exists p greater than 0 such that for all x belongs to domain of f of x plus p is equal to f of x. P is any positive real number, and if we are adding this p in x, so this function does not change. It is equal to again f of x. So this is not changed. So such a function is called the periodic function, and such a positive number p, when we add this p into function, it is not changed. So it means that period of f of x is equal to p. Now, example for the period or periodic function. First one is in a test pool for new lifeboats. A generator produces water waves according to fixed pattern. Since if the if the water is still and the surface where the water is present is smooth, then if we put a generator in the water, then due to vibration of the generator, there are the waves which are produced in the water, and I have made a graph for this. Uh, this is the height, which is taken as at x-axis, and this is the time, which is taken as x-axis. Height is taken as y-axis. So we can see that uh, at this point, the wave has height or amplitude 0, and then again at this point, its amplitude is 0. So length of this interval is actually equal to 6. This point is -6. And again, if you can see that at this point, after this point, its height is becoming 0 at this. So distance between these 2 points is also again 6. So it means that this graph is repeating its position after every 6 units of times. So its period is 6. This time is taken in second, then it means that its period is 6 seconds. So period is actually the smallest interval after which the graph is repeating itself. So next example is uh, constant function. This one. Every constant function f of x is periodic with no period. So uh, it is clear from the name of the function. This is constant function. We can also represent this like that. 1, 2, 3, these are elements, and here is A, B, C. We have to map every element at one element, any one of element. So this function is fixed. Every input has same output. So this is the constant function. Constant function. So this is its notation. We can also write constant function like that. Since this function is not changing, so we can also say this is a periodic function by default, and its period is 0 because it is never changing. Now, next, this is the example. If the period of f of x, this one, the period of f of x is p, then the period of f of kx is p over k. Uh, I would like to write here period of f of x is p. F of x has period p. So then what is the period of f of kx? Wait, what is k? K is some uh, real number, any real number. Since p is the period of f of x, so we can add this p into kx by definition of the period of the function. So we can write this like that. We multiply this by k and divide it by k plus p. So f of k times k is cancelled with this k. We have to divide with also with k, sorry, k. So x plus p over k. So if you look at the definition of the period, if we add this k, this p over k into x, this function is not changing. So it means that period of f of kx is p divided by k. Okay, now I'm going to the next example, this one. If period of f of x is p, then f of x minus c has the same period p. How can we prove this one now? If period of f of x is p, then what is the period of uh, f of x minus c? So how can we prove this one? Suppose I take this one g of x is equal to x f of x minus c. I'm assuming that this f of x minus c is equal to some g of x. Now I want to calculate this g of x plus p. What is g of x plus p? This is actually f of x plus p minus c. We have to write here in this place of x, here x plus p, and also here x plus p. So g of x plus p is equal to f of x plus p. So we get this. Now, what is this f of x plus p minus c? We can write this like that. F of x minus c plus p. Since function of f is p, so it means that this is equal to f of x minus c. So what is x? F of x minus c. F of x minus c is equal to g. So we can write this like that, g of x. So now we have obtained g of x plus p is equal to g of x. So period of g is p. Now what is g? G of x. G of x is actually f of x minus c. So period of f of x minus c is p. So these are two important results, this one and this one. Uh, it is recommended to use these results. You should be aware to use these results. This proof is not very important because it is outside the scope of this course or this book, Analysis-1. But you should be aware of using these results. Okay, next, little tougher example, that the graph of the function sigma, where sigma of x represents the distance from x to the nearest integer. So its period is 1. Now, what is sigma of x? Sigma of x is actually distance of x from nearest integer. uh, I'm drawing this real line here. Suppose this is 0, this is 1, this is 2, 3. So suppose I uh, wish to calculate the value of sigma at 0, suppose. So for integer, distance of 0 from nearest integer. What is the nearest integer of 0? This is 0. So sigma of 0 is actually 0 minus 0, which is equal to 0. How can we calculate the sigma of 0.3? This is between right at the mid of the 0 and 1. This is 0.5. So 0.3 will be on this side, 0.3. So distance of this 0.3 from its nearest integer. What is the nearest integer of this 0.3? Nearest integer of from 0.3 is 0. 1 is far away from this 0.3. So whenever we find the distance, we subtract. So distance of 0.3 from 0 is actually 0.3. 0.3 minus 0, this is 0.3. Now, what is the distance of 0.5, the image of 0.5 under sigma? So this 0.5 is now at the mid of the 0 and 1. So 0 and 1 are equidistant from 0.5. So you can do this in the both ways like that. 0.5 minus 0, this is 0.5. Or you can also write this 0.5 1 minus 0.5. This is again 0.5. Now you can note that I am subtracting smaller number from the greater number because this sigma of x is defined as the distance, and distance is always taken positive. So I have to subtract smaller number from greater number. Now, what is the image of this? This is 0.5. What is the image of 0.7? Now, where is 7? 0.7. This will be 0.7 at this point. I'm making it green. This 0.7. Now, this is closest to 1 as compared to 0. 0.5, nearest integer of 0.5 is 1. I think you should be aware that what is the integer. 0 is integer, plus 1 is integer, negative 1 is integer, plus 2 integer, negative 2 is integer. Decimal numbers are not integer, these are integers. So if we are interested to calculate the sigma of 0.7, so how can we find this distance? 0, since 0.7 is nearest to 1, so we have to subtract this one, 1 minus 0.7. which is equal to 0.3. Similarly, sigma of 0.8, this is equal to 1 minus 0.8 because nearest integer of 0.8 is again 1. This is equal to 0.2. If you calculate sigma of 0.9, so this will be 1 minus 0.9, which is equal to 0.1. Again, if you calculate sigma at 1, this is also equal to 0 because distance of 1 from nearest integer of 1 is 1. So its distance from itself is 0. Now, I would like to draw its graph here. This is its graph. Suppose this is 0 and this is 1 and this is 2. So what is the value of function when x is equal to 0? It is 0. So I have to make a spot here. What is the value of function when x is equal to 0.3? At 0.3, this is 0.3. Suppose this is 0.3 and this is also 0.3. So where is 0.3? Similarly, at 0.4, its value would be 0.4. So this would be 0.4. So this is another spot here. Uh, I should make it like that. So at 0.5, its value would be 0.5. 0.5 should be here at the middle of 0 and 1. So, and this would be 0.5 at the y-axis also. So up to 0.5, this value is 0.5 is the same as input. At 0, its value is 0. At 0.3, its value is again 0.3. 0.5 at this value is 0.5. So up to this 0 and 0.5, its value is the same as input. So this is the straight line in this case up to 0 to 1, 0 to 0.5. So now if you move at 0.7, its value is 0.3. At 0.8, its value is 0.2. At this 0.6, its value is 0.3. So we have to come down at uh, 0.6, its value would be 0.4. Now you have to make here a point at 0.7, its value is 0.3. At 1, its value is 0. Now it is coming back. Should be a straight line. It is meeting at 1. If you can draw this graph accurately, that's some graph paper, so you will get like that. Similarly, if you calculate the value at 1.1, 1.2, 1.3, and up to 2, you will get the same curve like that. First one. So now it is clear from this graph that this function was 0 at 0, and then its value is 0 at 1. Now its value is 0 at 2. So after this interval, this function is repeating its value. After 1, each 1, this function is repeating its value. So it is a periodic function with period 1. After 1, this function is repeating its behavior. So this is the way to find its graph and the period. Graph is the best way to find its period, and these are also some tools to find the period of the function Uh, these are examples as well as these are ways to find the period of the function.